Dear students, today we are going to discuss about monostable operation of timer IC-555. Monostable multivibrator is also known as one-shot multivibrator. As its name indicates, it has one stable state and it switches to unstable state for a predetermined time period t when it is triggered. The time period t is determined by the RC time constant in the circuit. Monostable mode of 555 timer is commonly used for generating PWM waves. Monostable multivibrator has one stable state and one quasi-stable state. It is also known as mono-shot or one-shot multivibrator or univibrate. It remains in its stable state until an input pulse triggers it into its quasi-stable state. It stays in quasi-stable state for a time duration determined by an RC timing circuit. The output returns to its original stable state automatically at the end of the time and stays there until the next trigger pulse is applied. Therefore, a monostable multivibrator cannot generate square waves on its own like an astable multivibrator. Only external trigger pulses will cause it to generate the rectangular pulses. The functional block diagram is shown here, and this is the timing sequence of monostable multivibrator. The functional block diagram and the timing sequence, and this is the pin diagram or connection diagram using 555 timer circuit. We can see the working of monostable 555 timer IC. In the standby mode, the control flip-flop holds Q1 on, thus clamping the external timing capacitor C to ground. The output pin 3 during this time is at ground potential or low. The three 5 kilo ohm internal resistors, that is the voltage divider network, act as voltage dividers providing bias voltages of 2/3 VCC and 1/3 VCC respectively. Since these two voltages fix the necessary comparator threshold voltages, they aid in determining the timing interval. Then see the lower comparator side. The lower comparator LC is biased at 1/3 VCC. This already we have seen in the previous video lectures, and it remains in the standby state as long as the trigger pin 2 input is held above 1/3 VCC. That means lower comparator LC is biased at 1/3 VCC and it remains in the standby state as long as the trigger input is held above 1/3 VCC. When triggered by a negative going pulse, the output of the lower comparator goes high, setting the flip-flop with Q is equal to 1, Q bar is equal to 0. This turns the transistor Q1 off and the output goes high, approximately equal to VCC. Since the timing capacitor is now unclamped, the voltage across it now rises exponentially through R towards VCC with a time constant RC. After a period of time, the capacitor voltage will equal 2/3 VCC and the upper comparator resets the internal flip-flop. That means after a period of time, the capacitor voltage will equal 2/3 VCC and the upper comparator resets the internal flip-flop. This makes Q is equal to 1 and the transistor Q1 is on. This in turn discharges the capacitor rapidly to ground potential. As a consequence, the output now returns to the standby state or ground state. Okay, you can see the timing sequence of 555 monostable multivibrator in this slide, and the circuit triggers only on a negative going pulse. The circuit triggers only on a negative going pulse when the level is less than 1/3 VCC. Once triggered, the output will remain highly until the set time has elapsed. That means once the triggered, the output will remain high until the set time has elapsed, even if it is triggered again during this interval. Okay, which is indicated here in this timing diagram. Okay, thank you.